So using a standardized method with a new equipment, you have to validate. But then, kung standardized method, again, kag ang equipment yung amo mo nagyapon ginagamit nyo, it's verification na lang. Meaning, hindi na tanan-tanan nga validation parameters i-perform. A few na lang parameters from the method validation should be performed, and that is verification. Now, if you have modified the standardized method, atong last time nga example ko, example, if naga-waste minimization ang lab. So instead of having 100 ml sample as required in the standardized method, nagamit na lang kamo ya 25 ml. So less reagents, less waste. You have to perform validation. Kaya nga gin-modify nyo ang already standard na nga method. So any modification should be validated. Okay? And if you have also developed in-house methods, you also have to perform method validation. So ano na siya ang method validation? No? How is it different with verification? So verification here is the process to demonstrate the competence in test performance of an already validated standardized test method. So, gaano ka mo actual example para maintindihan nyo talaga. Okay, yeah, you remember your last laboratory activities at TSS, total suspended solids dried at 103 to 105 degrees Celsius. This is standard method from the, ang reference naman is, um, standard methods for examination of waste of water and wastewater. Amo na siya ang book. So it's already a standard method no halin sa book. But then if we decided to kinaga-waste minimization ang lab, if we decided here nga magpipet na lang instead. So pero anyway wala adigali ma-save no all process why isang chemical nga gamiton. Instead, ang drying process lang because instead example of 100 ml volume, 50 na lang ang gingamit. So it is understood nga ang drying process would be not as long as 100 ml. Okay. So here, because you have altered, gin-modify mo ang volume nga 50 ml na lang instead of 100 ml. So this is what I mean nga ma-perform ka naman sa method validation to check if the 50 ml volume is the same ang result sa 100 ml volume. So you have to do sa una na siya, it is required to have at least 10 times nga replicates. But now, I think it's 30. Imagine that. No? Amo na siya ang requirement. That's why, amo na ang ko, dapat may pasensya agad kung ara ka mo sa analytical lab and if you really wanted to generate accurate results. Okay? So, balik ta sa... if you would want another example, dali lang. Ammonia. So, here. for the analysis, for the determination of ammonia using phenate method, this is spectrophotometric. So again, this is based on from the 2017 standard methods of examination of water and wastewater. So this is a standard method, but since ang phenol is also expensive, and so with the rest of the chemicals. So in here, instead of using 25 ml of the sample, we now opted to use only 5 ml. So na-reduce na ni siya ang mga ang mga chemicals na ni nga ginapang-add. Then na-reduce naman ni siya. Okay, so 25 ml, nag 5 ml na lang. So instead of this, nahimo na lang siya 0.25 ml ang phenol, then 0.25 ml ang sodium nitrophosphates. So see, kung ang paano na siya nga minimize mo ang cost, at the same time, you minimize the waste. But then, you have to prove na ang imo na 5 ml na sample nga result with all of this modification is also the same as when you use 25 ml. So, dapat naka-document na siya. Kaya ginapangita man na sa auditor, why did you modify the method? Is the result, are the results accurate? Amo na siya bala. Pareha man na siya sa wala na modify na method. Amo na siya. So, again, documentation is necessary as an evidence nga ang results are still accurate, even if you did method modification. Okay? So, muna siya. Then we go back to the slides. Any questions so far? Kainshinde ka mo? Next. Okay. So in the verification process, no, as ang standardized method, it is defined as the process to demonstrate. Mga magaling class na demonstrate, meaning you have also to prove, if you have to have evidence, no, showing the competence in test performance of an already validated standardized method. So the tools are the same for validation, but the lab needs only to verify that the document performance characteristics can be met. So example of the characteristic is accuracy and also precision. So you don't need to do all the 8 validation parameters, only a few for verification. Okay. So when you do method validation, you are checking the characteristics of the analytical procedures or methods, especially here, ruggedness, robustness, variability caused by day-to-day variations, especially the laboratory condition. The example, it is a routine procedure that every day, gina-check na siya ang laboratory temperature and also humidity sa aga and then sa hapon or sometimes in between, but dapat at least twice na siya i-check to 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 know kung may variations ang ano ni siya, ang values that can affect the laboratory activities, especially results. So tanan na siya naka-document, example pagsulod sa lab ginpaandar ang aircon, so ang parameter nila should be 25 degrees Celsius at 40% humidity, example lang. So, dapat every day na siya i-check and evaluate if there are changes, no, and how does it affect the performance of a method. Ka-id-ed ko na sa AnalChem lab. Then you have also to check ang analyst to analyst na accuracy and precision. Kung the same method ging perform ni analyst A, tapos si analyst B nag-perform man the same method, the same sample, ano ang ilan na duwa difference, no? Na-generate nila more or less jutay lang nga deviations or may aragad sang significant difference, no? Meaning, ang skill ng analyst is also challenged here, no? Para maka kuha sila sa result na precise and accurate. Then also lab to lab variation. So example, ari kami di nga lab nag-analyze kami the same sample. Tapos ang sample naman na siya, the split sample gin-analyze naman sa other lab. So dapat more or less parehas man ang results, no? Although there are some gamay-gamay lang yun nga difference. Next, instrument to instrument. So again, if you have two spectrophotometers using the same method, gina-check mo na if ano ang difference, is it significant or not na. Then also the columns, if you have liquid chromes or gas chromes, and also if there are kits, no, reagents are also checked, and the stability also of analytical reagents. Okay, so aside from this one, ruggedness, robustness, and variability, other parameters are also checked, especially linearity and range. Maghambal gani nga linearity, this is more applicable sa mga spectrophotometric instruments. Nga, di ba, nga ang applications ng Beer's Law. Okay, so i-discuss naman ni siya later. Then, specificity of a method. Like, hindi na nga, example ko, nga ang method for ammonia in water is different from the method sa ammonia for soil. And then, if you are familiar with spectrophotometers, di ba, kada analyte may specific na siya nga wavelength. Like for ammonia, I think it's 640. For nitrite, it's 510 nanometers. So at 640 for ammonia, hindi mo na siya magamit nga sa 510 for nitrite. Amo na siya ang example of method specificity. May ara gyud siya yung assigned wavelength. Next, sensitivity of a method. So this refers to the limits, no, of detection, limits of quantitation. Ano na siya ang pinakagamay nga presence ng analyte nga ma-detect niya. Ano ang limit nga pwede niya ma-detect? So we have here limit of detection and limit of quantitation. Okay, when should validation be made, no, in a method? When there are changes in the established method, like for example, may mga modifications kamo, especially in the amount of the sample or reagents used, and new method developed for a particular problem. So example, for like a specific problem, ano being a problem, okay, sa ammonia na lang ta again. So for checking on ammonia sa mga iba naman nga matrices, wala ka mong method sa lab. So you have to develop for that matrix. So you again have to validate the method. Next, establish method used in different labs, different equipment, or different staff. Okay, so whenever you have this condition, different equipment, or different staff, you have to do method validation. And when you have out of control situations within internal quality assurance, what are the examples of out of control situations? We have discussed, no, taton gid I think ang qualities ng reagents, di ba? Ang first na to na discussion. You are familiar with quality assurance, no, internal quality assurance. So example again, mas stop share ko kay pakita lang kamo sa actual na example. Dali lang gid class sa kaya pangita lang ko sample. Okay. As an example, we have here the quality control chart for ammonia, determination of ammonia in water. Okay, so we have here the mean, the red one, muna siya, oh. And the points are represents your internal quality sample in every analysis. So may ruling na siya class na dapat hindi siya mag over sa mean minus 3s or mean plus 3s. So you have here the orange and you have here ang orange color is mean. Ang average niya minus 3s and then mean plus 3s, this one. So makita nyo siya ang brown here. Makita nyo din siya nga in every analysis, never get na ang internal quality standard nag fall above or sa within the lines ng mean minus 3s. So which means nga all of the points no initial internal quality control ni siya na reagent no in all of this period no the analysis is within control no so ang meaning that the lab is performing well when it comes to the determination of ammonia. So makita yung na siya kay whenever my points din nga nag-deviate siya nga naglayo na gid siya meaning you have to do something kay out of control na siya. You have either to stop the analysis and troubleshoot. That's why amo ni siya ang role sa quality control chart, no? It directs you kung ano ang himuon or shows to you kung ang imo na um, process in the lab, how you do it, ang chemicals nyo are still within control, no? Mayo ang quality. Okay? So that's why once again, may speaker kami before nga din-introduce niya ang topic on quality control charts. That's why some other labs ng upod namon, natingala sila, what is quality control chart? So ang speaker naghambal nga, if you don't have quality control charts in the lab, then your lab has no quality at all. Okay? So I will also teach you gali kung paano maghimo sang quality control chart, no? So I think sa later end na ni siya or sa anal 2 ang topic. Okay? Ginagaan lang kamo sang overview sang importance nga dapat may quality give ang lab, no? Whenever it performs specific test. So may amo ni siya ang one tool of quality control and quality assurance implementation in the lab, ang quality control chart. Okay? Amo na siyang tsura. After that, balik sa okay. Next, non-successful participation in proficiency testing. What is this about? No? As an analytical laboratory, and to show that you are competent in your own field, dapat kapasar ka mo sa proficiency testing. Ano ni siyang proficiency testing? No, this is an activity given by a third party service provider. So if you are all like 50 laboratories, you are given the same sample pero blind class ang sample, tawag blind sample. Kaya wala ka mo kabalo kung ano gina siya ang concentration. Again, para hindi tayo maglayo sa ammonia na lang. So, gaan ka muna isang samples for ammonia determination, ang 50 na labs, no? Or those that uh, wants to participate, no? So, after that, gaan lang na kamo sa range nga ang ammonia nga sample, it's 0.5 to 5 ppm. So, imagine, kadako sang range yun, 0.5 to 5 ppm. So, ang challenge da is, how near are you to the assigned value? So example, ang assigned value that sang PT provider is 2 ppm. So meaning, kung ara ka sa 4 ang result, may layo-layo ka na gadi. Okay. Sa assigned value. So again, you have to troubleshoot what are the factors nga ang kalayo sa imo sa assigned value sang PT provider, no? And also, it is a reflection na ang laboratory nyo is not at all practicing GLP or wala gid ang quality. That's why you have to strive for excellence. Dapat makapasargi ka mo and dapat ang mga analysts niyo should be trained enough, no? Para at least ang skills nila, they can apply in joining the proficiency testing. As here as an ISO laboratory, you are really obliged to participate in proficiency testing yearly. So gusto-gusto, pag class, kay one sample cost like 16,000 pesos. So kung hindi ka nakapasar, you have again to re-enroll. Ka, diba? It's a non-compliance, no? Kung i-audit ka mo sang ISO being provider, no? Sila na ang accrediting agency. Kung i-audit ka mo, tapos wala ka mo yung kapasar sa proficiency test. So, what does it mean? No? It means na poor good ang inyong laboratory performance. So, again, joining and passing the proficiency test is a challenge to the staff and also to the laboratory management as a whole because it is a reflection of what they're doing. Okay. Next, demonstration of equivalence between two methods like rapid new test against a standard method. So one example is, di ba may nakamu standard method, tapos nag-develop kamo isang test kit, no? Which can which can be used in the field, no? For example, again for ammonia. So, gaan ta naman kami sa example. We're using the standard method, but we also develop a test kit for use ng mga fish farmers sa sa mga aquaculture ponds. And we also validate it against the standard method. Gaan ta naman kami example sa sa test kits nga na-develop namon. Okay, for a while. So, ammonia, man tagyapon class na kay para consistent. So, if you could remember kanina ang method sa finite method, and this is what we have developed based on that laboratory method. So, amo ni siya ang test kits nga gin-develop namon. So, you remember kanina, it's 5 ml lang ang sample, tapos i-ma-add sang 1 ml nga phenol. And here, we have here 5 ml, kagina, di ba, 25 ml sample. Tapos, we added 1 ml na phenol. Kagina bala sa method to, again show ko sa standard method. Then, we develop a test kit for use in the field. So, instead of the 25 ml, we use na lang 5 ml para ma-minimize ang cost. Then, instead of the 1 ml na phenol solution, we use 0.2 ml. So, in here, we have here procedure nga dapat so simple nga maski sino na like high school graduate or maski fisheries graduate maka-engineer and makahimo siya mismo sa farm, no, sa aquaculture farm. So after that, di ba kagina sa procedure, we use 1 ml sodium nitroprusside. Tapos diriya, because we're using 5 ml sample, nag 0.2 na lang siya. So 0.2 or 2 drops of reagent number 2. Kaya kung kisa hindi mo nakaintindi ang mga field technicians sa mga sodium nitroprusside, so we just call it reagent number 2. And for the phenol, reagent number 1. Then the mixed reagent, we have here reagent number 3, Clorox, and alkaline reagent. So let's stand for an arc. Di ba wala yaman yan mga spectrophotometers sa field. No, so develop the color for 1 hour and nag-develop na lang kami class ng color chart. Wait lang, kapakita ko. Class, can you see this one? Kita niyo din?
Yes, miss.
So, ang color ni siya nga ano naman sa computer, exactly is the same color as when you are using a spectrophotometer. So, may kaya ginahapo ko sa kasagdan din.
Ginawa, anay, miss.
Tama na siya ang challenge, diba? Kung chemist ka, dapat technopreneur ka man. So, dapat kabalo ka mag-develop sa method nga which can be easily understood maski sa hindi chemist kaya ma-implement nila sa ilan ng mga farms like sa mga milkfish farms, mga tilapia farms, shrimp ponds. So, amo ni siya. And then we're selling this one. Kaya na-validate na namon. Tapos, ang BFAR, ang Bureau of Fisheries, ang mga fish farmers sa Batangas, sa Luzon, sa Mindanao, they're also buying already this one, the one that we developed. Okay? And then, ginatudoan na lang kamo sa experience namon magnegosyo based on standard methods. Okay? Sa balik na sa lecture. At least actual. Okay. So, this is one example na at the kit. Then we also teach them how to interpret the result. Kaya diba, kung may result, anhon dayon nila ang result, kundi hindi man sila kabalo mag-interpret, no? Okay, paano na nila i-apply ang result sa ila na farms. So we also teach them the relationship between the toxicity gali of ammonia and pH. So you should have a pH value to determine toxicity. So mo na siya. Natudloan na naman sila. And then, how to compute. So basic, so basic. Bringing the lab sa field. No, so this is one example of a developed method based on the standard method. Okay. Next, balik tayo sa lecture. So here, ito. Here. Demonstration of the equivalence between the two methods, the one that we have developed, no, the rapid new test against the standard method. So dapat you also have documents, validation, records, just to show evidence that the new test is more or less the same, has the same result with the standard method. Okay, so we go to validation strategy. Okay, so specific test requirements defined by customer or the market. So the one that you will be making is based on demand. Dali lang gid class ah. Hello? Yes. Bye. So, balik na din. Sorry lang, may intermission. Specific test requirements defined with the customer. So of course, di ba, kaya if you are in a laboratory, all that you do is really defined by either the manufacturing plant, no, di ba, the customer or the market. Okay, so this is the first one. Dapat demand-driven or defined ang requirements for the test. Next B, you do characterization of the test method. That we will have to discuss no, in the next slide. Then C, you have to compare the method characteristics with the requirements. And D, you have to verify to give proof that the requirements are fulfilled. So maghambal din nga give proof, meaning you have really to write, no, you have to document, no, showing that the requirements are fulfilled. So description of the test method, of course, you have to identify then the scope, no? Next, ano na ang scope, no? This is, ganta na lang ka may example karon. Next, we have your reagents and materials and certified reference materials. You will be needing this, no? If you, in your standardization. Next, calibration of the equipment. Next, test performance, including safety instructions. And here, documentation, reporting, and you have to have your evaluation criteria. Sorry. Okay, so for identification and scope, you have to define the parameters in which the matrix maghambal ka gani klase matrix, dira na siya na-embed ang analyte. So it could either be soil, water, fertilizer, no, kung ano man da siya ang, or food. Next, for calibration, you will be needing calibration of the equipment and also defining the environmental conditions in the lab. Pag-perform ng test, anong temperature, anong humidity. Next, sampling and sample preparation. This is big consideration in testing. Kaya diba, about 60% of the errors halin sa sampling and sample preparation. Ang machine niya ma-read na malang na, no, sa whatever is the result sa imo nga sampling kag sample prep. This is one topic that you should really concentrate. Kaya diba sa AnalChem, amugan na siya ang, as I have said, big part of the errors occurred in sampling and sample preparation. Next, very important also is quality assurance na under dira ang quality control. This will be our next topic after we're done with this validation. After that, uncertainty or procedure for estimation. Of course, after the test, you have to compute for the uncertainty of measurements. Ano na da siya ang mga errors na nag-contribute, how much more or less, so it's estimation. Okay, now for the determination of method characteristics, amo na siya ang characterization of the test method. Under that, we have here characteristics of accuracy. We have here characteristics of the range, characteristics of the accuracy, specificity, robustness, and ruggedness. I will explain later in the next slide, and also characteristics of calibration. Then for characteristics of calibration, we have here linearity and sensitivity. So linearity is defined by the correlation coefficient, no, R squared, should be near to 1.0. So I will give you one actual example. Farewell. Sa ammonia, mantag gyapon class pero hindi ka mo magtalang. The same lang gyapon ang aton nga analyte. Ammonia. Let lang gada ang tao kung dalang gad. Hindi ko makita sa phosphate na lang. Okay, so phosphate. Okay, class, this is one example of a calibration curve for phosphate. So, may ara kami gintimpla na different concentrations of the primary standard. 'Di ba? Ano gani? Can you remember what primary standard is? 'Di ba? High molecular weight, very high ang purity niya. And what else? It's not hygroscopic, it should be stable. So for phosphate analysis, we choose potassium dihydrogen phosphate. Then after that, nagtimpla kami sang 2.5 ppm which serves as a standard solution. 2.5 ppm phosphate ng phosphorus. Okay. So from the 2.5 ppm, nag-prepare kami sang working standard. So at from the 2.5 ppm, nagtimpla, of course, you have the zero, then 0.05, kaya di ba, C1V1 equals C2V2, no? So your C1 is 2.5, remember nyo na ang competition, is it GenChem? No? Tapos, ang total volume here is 25 ml. So, after that, nagtimpla from the 2.5, 0.05, tapos nag 0.1, tapos 0.25, 0.5 ppm, 0.6, and 0.75. So, these are the volume, no? And ano galing gamiton nyo when you are preparing working standards? Di ba, dapat volumetric pipette, sinabalang daw bulb pipette, hindi na siya, wala na siya gradation. Nang dogahabok, nang siya bala nga, it's really equivalent to 1 ml, 2 ml, 5 ml, wala siya gradation numbers. Okay, then you also use volumetric flash, no, to the volume na dapat i-dilute siya. So here, hamon na siya class, basta ga-standardize, volumetric tanan ang glasswares. Okay, so going back, ara na ang ato na potassium dihydrogen phosphate, tapos ginread ta na siya sa spectrophotometer. So we have here duplicate readings, no? At least, no, duplicate. And then we have here the absorbance minus blank. Kaya ang zero ta, may reading siya nga 0.004. So dapat i-deduct na siya sa readings sa nga may concentrations na. So amo na ni siya ang values ng absorbance minus blank, no, sa spectrophotometer. After that, then plot na ang points. So amo na ni ang resulting, no. This is one here is absorbance, ang reading sa spectrophotometer. And this one sa x-axis, ang concentration. Ara. Okay. After that, plot na. So, using equation of the line, i-check nyo na dayon ang regression. Kaya diba, ari, malana di sa anoon, sa formula na sa Excel. Ari, o sa formulas, stat. Na. So, i-check nyo na ang regression. Kasi diba dapat na-define to kagina sa slide, it should be near 1. So, kagina to sa slide is 0.99 something. So, meaning, the line is smooth, no, okay siya. And you will now be using this equation to check the unknown. Ang Y nyo stands for the absorbance, which is given kung nag-analyze ka mo. Kaya diba, amo ni ang readings ng spectrophotometer. Then you have here the slope based on your equation of the line, ang 0.629. So now X here is your unknown concentration and 0.0008 is the intercept. Kasi bala ang equation sa line is Y is equal to MX plus B or minus B, the intercept. So here, amo na ni siya ang inyong nagamiton for computing the unknowns. And you have here the unknown. No, you use your the different volumes sang sample. Then you read it in the spectrophotometer. So again, absorbance minus blank. And then you substitute the values to get the X or your unknown concentration. Amo na siya ang example sang ato na ginang ariyo. Okay. Nagbalik na ta sa slides. Can you see now the slides again? Class.
Yes, miss.
Sinata to? Okay. So, correlation coefficient no, should be near to 1. Sa amo na siya ang meaning. You will appreciate more of this kung ara na ta sa spectrophotometric measurements no, sa actual, sa lab analysis. Kaya you will also be doing laboratory analysis and what virtual or whatever using spectrophotometers and you will be using the equation kagina. But again, what if ang inyong regression is 0.89 na or 0.91? So meaning something is wrong with the preparation of your reagent base sa inyo na measurements nga hindi smooth ang line niyo no. So that this is also to guide you na something is wrong with your technique or your instrument. So that's for you to troubleshoot. Okay? Next, sensitivity is defined by the slope of the calibration graph also. Kung kanina, graph. So, ang inyo itong working standard is also part of the sensitivity, di ba? 0.05 to 0.75 ang range sa concentration that you use. So, ang pinakagamay to na concentration based on the graph is 0.05. Okay, so this is also another example. Sino naman? Dali lang gad. Okay, so calibration value should be applied within the work. Ay, dali lang gad. Sino naman ni man? Hello? Hello? Hi. So, ang working range ta kagina is sa example ta is 0.05 to 0.75, no? ang aton nga the concentration of our working standards nga ginplot sa graph. So the lowest point should be the limit of quantitation. So what is the lowest point kagina? So it's 0.05 no ppm. For calibration, certified standard solutions shall be used, no? So, kinahanglan ged ang gamiton to kung wala mangged kamo sang di na natin. Certified standard solutions, pwede ged ang gamiton ta ang primary standard nga what is available in the lab. Basta highest grade ang purity, 99.99 something pure. Okay? Now, in addition, also standard solutions have to be added to blank materials to analyze overall process. For linear calibration functions, at least 5 concentrations are necessary. So, di ba kagina ang atong gingamit 0.05, 0.05, 0.1, 0.2, until sa 0.75. So, we did 6 gani, no, instead of 5. So, it is at least 5 concentrations. Next, test calibration functions for linearity and highlight failing linearity. So, kung di kanina line na to siya nga straight line. Sa pinaka end sang straight line, sometimes may tendency na kung nag-add pag ka mo add additional concentration or additional standard, may tendency na nag-curve is no longer a line, a straight line. So, ang point nga may tendency na mag-curve, amo na siya ang tawag nga ang pinaka line niya ged ang ends ang pinaka line niya na wala pa siya nagka-curve, amo na siya ang limit of linearity. Meaning, amo lang na siya ang concentration niya nga pwede siya maka-generate sang straight line with good regression. Ang after that, may aran na-reach na ang iyang limit of linearity which is not already applicable. Hindi na siya magamit kaya may tendency na sana nag-curve. So as analyst, as chemist, you must know kung ano it's by also by doing several trials. You must know kung ano ang effective concentration range. Okay? Per method. That's per analyte. Okay, next, on sensitivity, it is the difference in analytical concentration that corresponds to the smallest difference of a signal in a method which is still detectable. So, amo to siya ang pinakagamay na concentration. It can be extracted from the calibration curve or defined by using samples with different concentrations. Mas ma-appreciate yun ni siya class kung na-apply nyo na when you are already applying this one sa laboratory. Ako ganito na gabasa ka lang doon, mo gid mayo maintindihan, but then kung ikaw na ang nag-perform, mas ma-intindihan mo. Okay? Now we go to linearity, definition based on samples with varying concentrations, as like the example which I have shown you a while ago, and the calculation of the regression of results. Signal is the absorbance, di ba? It's the analytical signal of the instrument. Hindi na sa example ta because it's a spectrophotometer, ang signal ta is in terms of absorbance. And concentration do not have to be fully related. 5 standards of this, it's enough to produce a calibration curve if linearity is okay. More standards are necessary once the linearity is unsatisfactory. Next, examine repeat samples and standards over a particular working range to experience whether a reliable line can be drawn between proof and detection limit. But if you are already using a standardized method na based na yan sa mga books nga na-validate na, may ara na sila established na range of the concentration for the standards. May ara na sila. So, ano na nila na daan, i-upod na sa method nga use amo na siya, matimpla ka mo sang point zero something, then another standard, ginagaan na ka mo instruction. So you don't have to explore or experiment. Okay, so linearity of an analyte in a material, ara na siya. Amo man to gina ang ato na example. So this is in terms of milligram per ml ang concentration. And this is the um, absorbance. Ang absorbance Y gina siya. Sorry, particularly in this, ang Y niya is the concentration and the reference material in milligram per ml ang X. Okay, so these are the linearity statistics for your reference. And these are the accepted regressions. For Pearson is 0.9978. For this one, alkene and fat is 0.9985. But the nearer to 1, or grabe, gid ako nakakuha gid mo 1, no? Perfect. Next, we go to homogeneity of variances, characteristic values for the comparison of standard variations for differing concentration. So in case of great differences between standard deviation, the working range needs to be split. Ang working range sa kaginan sa example ta is 0.05 to 0.75. But then, it gave us already a good regression, no, or correlation coefficient. So you don't have to do or redo, no, because the variances are already in homogeneity. Next, determination of method characteristic. We're done with limit of detection and quantitation. We go now to the working range. Pero di ba may idea na makamukha gina sa working range? Ang best na working range of concentrations na makahatag sa inyo sang mayo nga linearity. So, finding out the appropriate working range using different matrices, so different samples or of varying concentration. Next, concentration range within the achievement of acceptable in terms of accuracy and precision. So in general, the working range is broader than the linear range. Okay. Prerequisites for calibration. Standards must be faultless. So dapat pure gid siya yan. Para wala na kamo sa iban nga pamansaron, no? In reference to the standards or chemicals that you will be using. First, it should fit for the purpose, and dapat, di ba, ang balance ng mayugid ang calibration, ang maintenance, kaya di ba, dira ka mo nag-weigh. So, kung may differences in weighing, it would also reflect sa inyong calibration line. No, hindi siya true picture sa actual na concentration, which should be when the balance is faultless and ang chemicals niya is also faultless. Precision has to be similar throughout the entire working range, and the model function is so linear, or is either linear or curved. Because there are times na especially kung ang opposite ang absorbance niya ginagamit, so we have linear line. But sometimes kung transmittance ang mode sa instrument, you will expect a curve line, a curve, no, it's not a line, a curve. So errors only may occur randomly within the signals, and errors have to follow the normal distribution. Okay, now we go to the limit of detection. LOD na siya class ng iyang abbreviation. So by calculation, X, or the limit of detection, is equal to 3 times the value of the blank. 3 times the standard deviation of the blank. Ato blank kaginang wala balas ng reagents. No? Sorry. Ang wala sang reagent, ang distilled water lang gadya nga ginset mo sa instrument to zero is called the instrument blank. So ang blank naman nga gina mention natin di is the distilled water plus your reagents without the sample. So this is the value of the blank. Next, okay. So generally, ang LOD is the mean of the blanks, no? That's the distilled water plus reagents plus 3 times the standard deviation of the blanks. So in other words, dapat damo-damo ang measurements mo, at least 10 readings of the blank para makuha mo ang standard deviation and mean para mas lapit kagad sa ano ni siya mas accurate kagad. So dapat damo measurements. Now in the new guidelines, I think instead of 10 it's already 30 measurements. So imagine that kung wala ka pasensya, no, to check on the blanks pa lang. Okay, so that's limit of detection, mean of the blanks plus 3 times the standard deviation of the blanks. Siya mag-calculate. Now, let's go to kagina, limit of detection. Now we go to the limit of quantitation. Ang pinakagamay nga quantities ang analyte nga ma-measure using the method and the instrument. So by calculation, LOQ or limit of quantitation, diri na lang to, is equal to 5 or 6 or 10 times the standard deviation of the blanks. Okay? Wala na yan sa mean. Kaya ba mean of the blanks plus 3 times the standard deviation of the blank. Here naman niya, ang LOD is, ang LOD is 5 or 6 times or mas diri na lang diri kami 10 times the standard deviation of the blanks. Kaya hindi ka mo class, difference, limit of detection of the method or instrument is equal to the mean of the blanks. So it's either 10 or depende kung pisan ka mo, pwede man 30, no? Plus 3 times the standard deviation of the blanks. Ang blank gina is the water nga diluent plus ang inyo na reagents without the sample. So that's the blank. Maghambal naman yung class nga blank na distilled water, it is an instrument blank. It is used to zero the instrument, no, especially sa spectrophotometer. Lain man ang reagent blank. Okay? So we're done with this. Linearity statistics. Tapos na. Ito. Okay, so we have here the LOQ is the limit of quantitation, limit of detection. Here, mas gamay ang limit of detection. And then we have the signal to noise ratio, this one. Sa instrument ni siya, SNR, signal to noise ratio. Daw mga interferences, pero it's ano ni siya, quantifiable. Depende sa instrument. Mera, ang instrument kung kisa nga pag ono pa lang gahod na. Okay. So the limit of the LOQ, this is peak B and the LOD. Initial class na this depends on the instrument kay pag on, so we have been the baseline, dapat ano na siya, diba? Straight kay baseline. Because of the noise, meron siya nga vibration or interference, no? So it also matters. Next, ang LOD nyo, it has here like peak A. Meron siya sang tawag sa signal diri, peak A, also for LOQ. In most cases, LOQ is greater than LOD. Okay, so another validation parameter is selectivity or specificity. It means it is an extent to which particular analytes ang mga substance of interest na gusto i-measure or i-determine. So extent to which particular analytes can be determined in complex mixture. A method which is selective for an analyte is said to be specific. So example, Rina, we have a method, a Fenwick method for ammonia. So it is specific for ammonia. Okay, so we have here, okay, selective detectors in instrumental analysis. Um, are you familiar with magkambagani nga detectors? Usually sa, ano ni siya, sa mga, uh, example is high performance liquid chromatography. Damo na siya class nga detector. Pwede na siya for UV no detector. It is one accessory. Then may ara man siya fluorescence detector. Ang UV na detector usually pwede na siya ma-analyze ang mga bioactives, mga what else, some antibiotics, but there are methods na nag-require sang fluorescence nga detector. So it's another accessory. Kaya hindi pwede ang UV. Next, some other requires refractive index detector because we will now be determining sugars, no? Ara, pati sa HPLC nga example So, pwede nga ang unit ng HPLC can have 3 detectors specific for the method. For sugars, switch na siya sa refractive index detector. For the instrument, to determine sucrose, fructose, kay kung iba nga detectors, hindi pwede, kay di specific for the method. Next, example naman, kung ang imo naman nga i-analyze is, ano example, antioxidants. Now, there are methods na nag-require sang fluorescence detector because hindi pwede ang UV na detector. So, imagine, to analyze many analytes na nag-require also many accessories. Kaya ang isa lang na detector is not suitable for another analyte. So, amo nang meaning sang selectivity in terms of instruments. So, next naman sa micro naman, sorry, selective media in microbiology. Now, there are selective media. Like for example, familiar ka mo sa Vibrio para hemolyticals, Vibrio calorie. May media na iya nga specific lang nga sila lang na siya ang matubo, no? Although pwede na sila katubo sa tawag na universal media, but then really kung gusto mo yang sila lang nga ang patubuon, di na natato. Okay, there are selective media nga ang specific lang gid nga species ng bacteria ang matubo. Okay, gina-inhibit niya ang iba na bacteria. So it depends on the nutrient composition or the composition of the media, no? Kaya ginabutangan man nila sa inhibitory nga mga substances to prevent other microbes to grow. Okay? Muna example. So, what is the difference between selectivity and specificity? So, selectivity, a selective method gives correct results for all interesting analytes, whereas a specific method gives correct results for the interesting analyte, whereas other analytes might interfere with each other. So, okay, so okay, mag-explain, no? But for specific methods, naghahatag lang siya result for a specific analyte, no? Ang iban nga mga analytes are interferences. So may ara na siya nga there are some techniques how to address interferences nga ang analyte lang gid of interest ang imo i-measure. Next, specificity outlines the analytical extent to which an analytical substance or group can be determined without interference from sample-related components. So, gina-screen niya balaklas ang possible interferences. No? So, this is specificity. It says here, oh, no problem. Usually, both words are mixed. Okay, so here again, further explanation. Method selective to one analyte substance specific. Method selective to one analyte substance specific. So, like, let's take for example the um, ano, ang procedure for testing ammonia.
The third.
Sige. Kabayad na sila, Reg. Hmm. Sa any class, makita lang kung method. So, ay, 12, nagaling na, dala lang dyan. So here is an example for, again, ammonia using the finite method. So we have here the interferences, so defined interferences like magnesium, calcium with citrate eliminates interference produced by precipitation of these ions at high pH. So remove interfering turbidity by distillation or filtration. So and etc. Next, ang method specificity is may ada siya defined nga wavelengths for reading sa spectrophotometer. So it's 640 nanometer. What about other analytes? Natanawan ta. For like nitrites. For nitrites, kay ammonia, it's 640. For nitrites, it's wait, last year. It's 510. Kita nyo? So, in other words, hindi nyo pwede magagamit ang wavelength ng ammonia para mag-analyze ng nitrite. Kay its method has its own wavelength nga dira makita ang maximum na absorbance ng analyte if present. That's why sa phosphate lain man ang daw 660 bala ang phosphate mo. So that is one example of method selectivity. Okay? Sa spectrophotometers na may ara gid wavelengths per analyte. Or else karon hindi na mabalaan kung ammonia na siya or nitrite if sa 510 siya ging basa or sa other wavelengths. Okay? So what else? Okay, so next, Maybe later this afternoon, we will continue before your laboratory. We'll finish this one if we still have time, or probably we can do a pre-lab also lecture, because later on you will be analyzing alkalinity in water. So that's actually class ang lab kaya advanced na kay dali lang yan. Sample sa panawag. So okay, let's resume at 2 o'clock for your pre-lab lecture. And next actual lecture, sorry, actual activity. And I will just send to you the procedure for this afternoon's lab activity. Actually, damo-damo, nakamagani na analyze kumpara sa face-to-face. Kaya diba, mas dasig. But be sure to study the method and also ask question kung hindi ka makaintindi, ha? And I hope sa next time may chance man nga maka-visit kamo sa lab. Sino na nakakadto di sa lab? Jude, nakakadto na kamo di sa lab?
Yes, Miss, ang 2016.
Sa inyo na ano, sa inyo na SIP?
Oo, Miss.
Ano ang inyong study about?
Nang about, Miss, nagamit kami shrimp nang gintas namon ang nalipat na po ko na nga substance, Miss, nag-affect sa heart rate lang sa
Okay, nadumduman ko na siya. Pero wala ka mo yan sa instruments, no? It's more on the counting muna.
Nagamit kami, Miss, ang rotavap, Miss, kag ang isang sa may ginadistill.
Sinadistill. And ano na siya, ng reflux.
Reflux apparatus.
So, okay na class. We'll see each other this afternoon. Kag ang analyst for the waters, we will be checking on total alkalinity, and also if my time, total hardness, and also compute calcium and magnesium hardness in water. So, i-check ko lang karon what are the samples na available. Kaya usually, ang sample namon are raw water, sa drinking water, and also finished product. But i-check ko lang kung mayroon kami other samples sa wastewater. So, okay. Gata na yun. Bye for now, and we'll just go back at 2 p.m. Okay na? Neil,
Miss,
there?
pwede ba Miss ang imo nga file, Miss?
Oo, sige. Ang file today, this morning.
Miss.
Sige.
Miss.
Ano naka-intindi?
Thank you,
Baka
Miss.
explain ko. Kung di ka maka-intindi, gagahatag na ko gani as much as possible para maintindihan niyo good. Ang amo din nga actual nga ginahimo nga mga charts, nga muna bala kay para at least ma-relate niyo bala sa ang applications niya, rather than puro lang theory nga doon din yung man gan mag-grasp ano ang gusto ko. So amo na siya. But then kung gusto niya pag further explanation kay diba, after that what you learned sa AnalChem, ma-translate ka na yan, ma-reflect ka na siya kung ga-work na kamo sa lab. Hindi lang din na siya pure theory, it's more on applications of the theory. So dapat maintindihan nyo get, especially ang good laboratory practice, no, quality control, assurance, no, ang amo na bala, mas amo na ang gina-expect sa inyo kag ang ang mga standardization. So later, you will also be dealing with standardization. Kay diba ang total alkalinity is acid base. titration. Or mas mayo siguro sa ano na lang taanay, sa simple lang taanay, neutralization no, sa acid-base nga titration and then alkalinity. So sa next na lang ta sang ano, complexiometric ang hardness and calcium and magnesium ions sa next na lang. So karon tuluan kamo anay how to standardize solutions, especially acids no nga para mag-titrate sa base. Amo lang na anay karon sa pinaka-basic. After that, total alkalinity na activity. Okay? So, bye na ko anay ha. Later, see you at top 2 p.m.
Thank you, Miss.